I thank coordinator Dr. M. CHINNAPANDIAN sir and co-coordinator Dr. K. Purushothaman for giving me an opportunity. I welcome Dr. Shafi sir. So Dr. Shafi is a distinguished academician and seasoned professional, and he is a prominent figure in the field of mechanical engineering while specialization in thermal engineering. His illustrious academic journey has been marked by significant achievements and contributions to both education and industry. He is driven by a passion for research and a thirst for knowledge, Dr. T. Shafiq. And so he pursued PhD at Anna University under the guidance of Dr. R. Velraj, former Vice Chancellor of Anna University. He had experience of 25 years in teaching. Also, he served 2 years in industry. He brings a wealth of knowledge and practical insights to his professional endeavors. His dedication is evident through various leadership roles, including serving as head of the department, program director, and principal of a polytechnic college. Beyond his academic pursuits, he also served as an NCC officer for the Navy wing, attaining the rank of sub-lieutenant. This role is not only showcased his commitment, and also his discipline to provide opportunity to mentor and guide aspiring individuals.
Thank you, sir.
Under his mentorship, many research scholars have successfully completed their program, reflecting their ability to inspire and guide the next generation of researchers. Currently, he holds the position of a professor in the Institute of Agricultural Engineering, where his expertise continues to shape the minds of future engineers. In addition to his academic responsibilities, he also serves as a ISO management representative for CIMAT's School of Engineering, emphasizing his commitment to maintain the quality management practices in their institutions. Thank you, sir. I will hand over the session to Dr. Shafi.
Good evening, one and all. Thank you, first of all, for Dr. CHINNAPANDIAN sir, as well as for Dr. Purushothaman sir, for coordinator for this Atal FDP program, and principal sir and mechanical department faculty members for giving me for that wonderful opportunity to perform my presentation to that FDP Atal FDP program. As well as I am thanking to the senior faculty members from other institutions also, that is for Pandya sir and others from other institutions, senior professors also. And once again, thank you for attending my session also. So the topic given is for agricultural energy storage conservation solution for farmers and ranchers. That is, agricultural energy storage conservation solution for farmers and ranchers. The agriculture is a backbone of our society, providing food, resources, and livestock. Moreover, with the increasing energy demands, rising cost, environmental concerns, farmers and ranchers are facing new challenge how efficiently store and conserve energy to ensure sustainable and cost-effective farming practices. So imagine a world when the farmers run on renewable energy, where excess powers from the sun or wind is stored efficiently and used when needed, reducing dependency of fossil fuels. Nowadays, the problem is for fossil fuel, for greenhouse effect and climate change, everything is there. So with the innovative solutions like solar battery storage, bioenergy systems, and smart grid technology, farmers can not only reduce the cost, but also contribute greener and more sustainable future. So now I am going to discuss about the few things in that for agriculture, energy storage, and conservation solutions for farmers and ranchers. Now, this is my overview of the presentation. The first one for energy consumption and cost in agriculture. Second one, energy storage solution and the energy conservation strategies so far followed in that, and some of the case studies for understanding purpose. Now, the slide is for energy consumption and cost in agriculture. That is, agriculture is that significant consumer of energy, that is approximately 5 to 6% of global energy consumption. It's accounting for approximately 5 to 6% of global energy consumption. Another one, the agriculture sector relies heavily on energy intensive practices such as, and the figure it shows for the top one for cultivation, that is for the help of tractor, that is for plowing and other things are happening. Then next one is for irrigation, and the bottom one for the turmeric cultivation. For example, I am given here for turmeric cultivation. Then another one for harvesting. So we are needing for that energy everywhere in that for agricultural activities. So from the use of a tractor as well as for plowing and tillage and other things are We need to carry it out with the help of tractor only. For that, we need for fuel for doing all those things. So India is depending largely depends on for the tractor for doing all those things. Then for irrigation, so the irrigation as well as for this cultivate tillage, everything need for energy. So the agriculture is a significant consumer of energy, approximately 5 to 6% of global energy consumption. So this is the main one for the consumption of energy in agriculture sector. So it's because of this energy consumption, the cost also automatically it may come. That is for consumption of energy. It's results in substantial cost for farmers and ranchers, impacting their profitability and competitiveness. So first one, the imagine so is for that cost. The another one for we need to survival on that society for making that one for profitability. Same time for competitiveness. For that, it's the image. Then another one for if you are depend on for reliance on fossil fuel, so contribute greenhouse emissions, exacerbating climate change also. So the bottom one for it's that's for gas emission, and one for due to that for climate change it's showing here. So this is the one for energy consumption and the cost along with all those things is coming. Then another one, that the importance of energy conservation in agriculture. So we can list out so many things. On the right hand side, we can go for improved environmental health, minimization of site environmental impact, then reduce the environmental risk, optimize the resource usage and conservation, high production benefits and low cost production, improved food production. So that is the sustainable as well as for conservation in agriculture. So water conservation also nowadays is the main one. Then improved energy security also is the main one, and for environmental benefits also. Then the next one is for overview of energy use in agriculture. That is, it contributes or it continues to be a most predominant sector of the state economy because it improves for with the help of agriculture only. It's standing that economy. So that 60% of the population is engaged in agriculture and allied activities for their livelihood. So the picture shows that for landholders, landless people, and livestock, women, and youth. So they are all connected with agriculture-based livelihood. So the state has an area of 130 lakhs of hectare with a gross cropped area around 59.2 lakhs hectare. That is for this figure shows only for the Tamil Nadu, the status of Tamil Nadu. For so far, the state has an area of 130 acres, lakhs of hectares with grass cropped area around for 59.42 lakhs hectare is they are doing for cultivation purpose cropped. Then energy use in agriculture, overview of energy use in agriculture. Here so many pictures are shown in that slide. When you are looking for the first one, that is for field preparation. I think olden days they have used it for animals. Nowadays we are using for that machineries for I think tractor is used almost for preparing that land preparation. So far we are doing all those things with the help of tractor and with farm machinery, equipment and attachments, everything is there. Then for even after field preparation, we need to go for seed sowing also. That is also need for machineries, or with the help of human they may do for labor may do for that manually. So that is also nowadays it's modernized. So seed sowing also it's with the help of machinery. Then finally these things are for consumption of energy. Again for field to be irrigated, that is to be irrigated. So field irrigation also with the help of energy. So we need for water and other things for sources of pump, everything is there. That is also for one of the energy used in agriculture. Then harvesting on the right hand side, that is also consumption of energy. Then for crushing, for removing the grains from the crop or the plant, that is are needed for that is also to be consumed by the energy. Then for combine harvesting, nowadays it's coming for combine harvesting. I think we have seen at the roadside so many. I think when you are crossing any from the village side or from that paddy field, they may use to do for this type of this kind of machine for all-in-one purpose. So everything is doing at one single stage. I think the olden days they have to they have harvesting and after that doing the grains from removing with the help of threshing. But nowadays they are doing all those things with the help of power for separating grains from that rest of the plant. So that is the olden days they may use it by hand, by animal, and with machines. That is now it's a combined harvesting. So it's cuts thrust clean crops in a single operation. So it's a combined one. For I think everybody have seen that at the roadside when you are crossing from villages for the mainly from the paddy field, they may use it for doing all those things. So everywhere in that energy is used for from that whatever may be that energy in terms of fossil or I think for solar or whatever it may be, they may use it, they may consume it for running that agriculture purpose. So this is the energy overview in agriculture. Then energy intensive farming practices. That is, first of all, we are coming into the top conservation of agriculture, then conservation of tillage, then crop rotation, then water management, then for cover crops. So these are the comes under for energy intensive farming practices. That is we are following also. That is the Indian. That is Indian. That is for manufacturer for crop production manufacturer they are doing for these all the things. Then first conservation and agriculture, that is you are keeping, I am keeping here for one three things. One is for conservation and tillage, under that for no tillage, another one for minimum tillage, then second one for soil cover, that comes for cover crop residue, mulch, then crop diversification, that is crop rotation, then crop mix, then intercropping. So what is conservation tillage? So first of all for no tillage. So no tillage is nothing but is zero tillage, means we are not doing anything. We are not doing in that land. Normally we need to do for cultivation. We are doing for going for cultivation purpose, means we need to do for all the activities, but we are not doing anything. But the thing is, immediately after harvesting, we are doing all those things for this tillage, that is called is for no tillage. So the energy is a less consumption. So no tillage, it's a zero tillage without disturbing the soil. The sowing seed directly to the soil means after previous or after that harvest. Immediately we are doing for the seed sowing after the harvest. So that is called for that is minimum tillage. Then here for soil cover, the soil cover, that is means we are covering that earth by way of in terms of residue, as well as for cover the crop. Some of the crops are there for covering all those things. That is for cereals, everything is then comes under the category for cereals, and all comes under the category for the cover crop for soil cover. And another one for mulch. The mulch also is the same. I think covering the bare soil with that with the material that is improving fertility, reduce weeds. That is comes under, for example, what are the things are we are using means straw, grass, and wood chips we are using for soil, covering the soil. Then crop diversification, that is means first one for crop rotation. So we used to do for crop rotation normally. So once harvested means we are going for another one, like that we are keep on changing that one. Then crop mix, then for intercropping. These are all comes under for conservation in agriculture. So once we do these two things means at least we can conserve the energy. So tillage, everything is I think by way of we are keeping all those three things if we are following means we can save the energy in the way of doing all those things. Then energy intensive farming, that already is, that is previously is listed. It's showing only for that what are things comes under for that minimum soil disturbance, means it protects the soil from erosion, then save fuel, time and labor cost, better water infiltration, then permanent crop cover, that is the recycling of nutrients, then for suppresses weed. So crop cover means mulching. Mulching is one of the way we can suppress the weed. Protects from soil erosion also by way of mulching. Then crop rotation, once again it's efficient water use, control pest, improve soil fertility, increase yield. So by way of we can maximize the yield through intensive farming practices. Then energy cost and their impact on farm profitability. Energy cost and their impact on farm profitability. So without from profitable, I think profit, nobody can work for that one. So here I am listed out for in the figure. First one is for machine operation, second one is for irrigation, another one for third one heating. So higher energy cost, that is directly increasing the production expenses of what are the things comes under for that is for profitable. I think reducing our profit means first one is for machinery operation, then irrigation, and third one for heating. So particularly related to machinery operation, because we are doing for all the machineries for that is a farm mechanization by way of tractor and tillage, all those things. Then irrigation also we are doing with the energy. Then heating also we need, that is which can lead to reduced net income for the farmers. So automatically it may affects the farmers. That is the arrow indicates for low income. The finally they may who will suffer means the farmers may going to suffer with the action of the above three things. But we cannot avoid it. But how we can minimize, that is the criteria for us to challenges for the farmers to solve the things for making a good profit. So rising energy prices translate to low farm profits due to increased operation cost. Once operation cost is increased, it means their profit also may be reduced. And for energy efficiency improvements, how we can improve the energy efficiency? That first one for implementing energy efficient technology on farms such as high efficiency motors. So the motors are used for irrigation purposes. Then LED lighting for that is for agricultural field. Then optimize the irrigation systems, so that is for sprinkler and drip irrigation. So many irrigations are there. So we have to find out which one is the optimum for us. That is optimize the irrigation system and can help reduce the energy consumption. So these are the way. Then another one for utilizing renewable energy options like solar, wind, other things. Then choosing crops that require less energy intensive inputs for consumption of water. And based on that, you have to decide. Based on the climate, also you have to look into that one for region and climate also. Then diversifying farm operations can provide additional income, streams. That is means we have to do all the activities simultaneously for in one field. That is for diversification in agriculture. That's only it's showing in that the last image. It shows that only. So we can keep that energy efficiency improvement means we can at least save the energy by way of making the profit for the farmers. For introduction to energy storage, we know that already. That is for energy storage system. The ESS is technology that captures excess energy generated during the periods of low demand. So whenever that the low demand, that time we can generate and we can store and we can use it for whenever it's needed for peak. So it's excess energy we can generate during the periods of low demand and stores it for later use. The store electricity generated from renewable sources such as solar panel and wind turbines. Then so when you are going for this one means we can avoid for grid. That is means reduces dependence on the grid. So when you are storing and we are generating means we can avoid the grid. That is showing for the two majors, one battery storage, another one for grid. So dependency on the grid may be reduced. So and ensures a continuous power supply also. So I think whenever if you are generated more than that of our requirement, we can sell that one also. That is option also is the government also provided that for the system. So that net metering system also provided for selling that option for that one. We can for the excess one we can sell it. And what is the need for energy storage in India? What is the need for energy storage in India? That is India has committed to increase its share non-fossil fuel based generation sources to 40% by that 2030. I think the nearby there is means share increase committed to increase 40% by 2030, which necessitates a demand for flexibility in power system also. So the next one is for power for all target. Power for all target 24 into 7 electricity for all by 2019 they created an increase in power requirement and need to balance supply and demand of electricity. So that is electricity for all, that is for power for all. They have scheme is opened, developed by, initiated by the year 2019, created an increase in power requirement and need to balance the supply and demand of electricity. Then energy storage will play a crucial role in increasing system overall flexibility by serving multiple grid application also. So energy storage means it's a multiple grid application also we can get it for overall flexibility by serving multiple grid applications also. So the recent development electrical vehicle sector and its ambitious targets will only increase the demand for energy storage systems. I think that because of the electrical vehicle, they evolved for energy storage system also for need of energy storage in India. Then energy storage systems that is classified into so many types. I think thermal energy storage, mechanical energy storage, hybrid, then electrical energy storage, chemical, then electrochemical storage. Already so many speakers already they have delivered from the day one to till now. I think before my session, I think again further classified into subdivided into that is pumped, that flywheel, lead acid. Yesterday that speaker presented for that one. Our Velres are also presented, or Gunnar also presented. Then thermal, sensible, then thermochemical storage, then electrical supercapacitors, SMES, then for chemical storage, then for power to gas, everything. Then importance of energy storage systems for farms for both small and large scale heavily rely on electricity to power irrigation system, machinery, and other essential operations. So without, I think irrigation and farm machinery, I think farm machinery equipment with the help of energy only, it's going to do all those things. Without that, we can't do anything. So we need to improve that one. We need to improve that. Taken care of that storage as well as for consumption as well as for conservation also. So that is essential in that nowadays. So the rural area often faces challenges related to grid connectivity and reliability. So some of the areas may not be get the grid connectivity, means the EB line may not be available. So that area, I think we need to rural areas are often, I think, faces challenge related to grid connectivity and reliability. Today I have just gone through that for one website. Is there any villages? Still they are not receiving any electricity. For one website is showing that it's no village in Tamil Nadu for no electricity, without electricity. But I'm going for in another one website, it's showing for nearly 38 villages. Still, it's need to connected in the grid. So they are still, I think, may not get that electricity for their villages maybe. And likewise for other state also they have mentioned in that one, but they are doing in that remark place, they are doing that they have kept on board, they have initiated and doing all those things. But so far I don't know how it is whether it is correct or not, I don't know. But I gone through that whether it is anything is without electricity villages are available or not. Then it's two websites are, one website is showing like that, another one is also showing in a different way for other states also in India. Then energy storage system addresses the challenges by offering sustainable solution that enables farmers to store and utilize renewable energy on site. By integrating energy storage system into their operation, farmers can achieve energy independence and reduce their carbon footprint also. So when you are doing for tractor operation and other things also making for that for climate change and for greenhouse gas emissions, everything that is to be avoided by way of keeping that is for doing for renewable energy sources for farmers and ranchers. And types of farms suitable for energy storage systems. And for cows are there, that is for livestock farm. Then another one for vineyards on the right hand side. The fruits are there. The image is showing for fruits. The vineyard and the orchard. It's for fruits and nuts for food or a drink. For example, the grape and other things are it's needed for this type of farm suitable for energy storage system. So what are I think which farm is mainly suitable for energy storage system? Means these are the things that are identified for that researchers. It's these are the thing it's mainly used for farm suitable for the energy storage systems. Again, the types of farms suitable for energy storage systems. That is one is for organic farming. We know that already organic farming without fertilizer we are doing all those things. That is, the organic farming means a sustainable agriculture, environment, soil health also improved, and the pesticides. I think it's showing for int mark, so you should not do that one. Then for crop rotation, we need to follow and compost. Compost means it's organic one. We need to prepare all those things. Then for residue, vegetable for crop residue also it's one of the compost. Then for biodiversity, then for food security. So it's going for that is organic farming also suit out for energy storage system. Then another one on the left hand side on your screen that is showing for that indoor unit for vertical gardening. I think we have vertical farming. So vertical gardening also is there. Vertical farming also is there. Then growing banana. It's I think it's growing banana in this way. I think for they are cultivating that one for in terms of vertical gardening also. But gardening is there, and they are doing for research and doing for vertical gardening in the banana tree also for that one. Then India energy scenario 2024. So this only focuses on for what is the energy, how its energy is growing on, what are the things are it comes for electricity, and what are the way they have produced. So the first one is for India plays a vital role the global energy transition because of its population, increasing energy demands, and impressive economic growth make its journey of energy crucial not just for itself but for the entire world. So whenever it's the population increased, that energy demand also keep on increasing. So that is the main one for that considering for the India energy scenario. So another one for rising energy needs. The primary energy supply is increased 54.5 percentage over the past decade. That is 14 to 23, 23 to 24, rising from 589 million tons of oil equivalent. That is million tons of oil equivalent to 910 million tons of oil equivalent. That is primary energy supply is increased due to population and other things. Then another one for total electricity consumption that doubled from 874 billion units to 1,543 billion units between 2013 to 14 and 23 to 24, growing at an annual rate of 5.8 percentage. Then India's peak electricity demand surged by 79 percentage, rising from 136 gigawatts to 243 gigawatts 15 between 13 to 14 and 23 to 24. Notably, on May 30, that 2024, the year 2024, India recorded an all-time high peak electricity demand of 250 gigawatts. This is the scenario for the Indian energy scenario. So due to that, the population and consumption of electricity only it's keep on growing on. Then solarization of agricultural sector. So nowadays, I think everywhere I think they are using for that. That is government also given the scheme for solarization to solar power. So India is an agriculture-based country with agriculture providing livelihood to almost 45.76% population in the country. Solar energy for irrigation is having sustainable and economical path for growing agricultural activities in India. So oil consumption in the agri sector has been steadily declining, with the electricity serving as the primary energy source, accounting 97% of the total energy in use in year 23 to 24. So now here it's the main one that is for oil consumption in agriculture sector has been steadily declining, with the electricity serving as a primary energy source, accounting for 97% of the total energy use in 23rd to 24. So here it's oil usage is I think it's reduced, declining way of from 23 to 24. So because of solarization of the agriculture sector, so all are forwarding towards that for doing all those things for irrigation and other things, everything for in terms of solarization. So it's a declining way of for oil consumption. So another one for the number of energized pump sets. So that the energized means here for electrical pump sets has increased from 189 lakhs in 12-13 to 272 lakhs in 22 to 23. So one that is a year taken here for 12 to 13 and again 22 to 23 for drastic improvement for increased pump sets. That is for installed 189 lakhs to 272 lakhs, reflecting annual growth rate of 4%. Meanwhile, solar pump adoption grew sustainability during the same period, rising from 11,626 to 5.2 lakhs, marking of 45-fold increase. So the 44-fold increase in for solar pump also. And the here it's showing for diesel consumption. That figure it shows for the diesel domestic production, and another one for import and another one for export. So when you are coming and looking in this graph, that quantity is MMT it's given. Here I think from that year it's showing 16 to 17 till 23rd to 24. So the green color it shows always high for the all year. It's gradually keep on increasing. That except 2021 it's reduced. Again it's going and elevated. So from the year 16 to 17 it's elevated 102 to 116. At the same time, that is for export also they are encouraging and they are doing for export also. But in for looking the graph for 16 to 17, they started with one, that is for import some oils from that other country. The 16 17 they imported, then 17 to 18 also they imported. Again they reduced the consumption 18 to 19. Again elevated for 19 to 20. That is for 2.8. That is import. That is another one for 20 to 21 0.6, 21 to 22.04, and 22 to 23.3, and 23 to 24.04. But the export is 28.2. So by seeing this one, that India is produced that diesel by domestic, I think by using for our own way of preparation for doing, that is for manufacturing of this one also. That is, I think trucks, tractors, and heavy vehicles are using. So diesel used for mainly in diesel engines. The high energy density makes diesel an efficient choice to power various machinery. So for considering for agriculture, all the for cultivation, for preparing the land preparation, everything to be used only with the help of diesel tractors only. So no other way to go to escape from that action. Otherwise, very difficult to do that performance. So it's the only heavy duty vehicle to do all those things for doing for agricultural one for diesel engine. Domestic production, I think the previous one and this one is not the same, but I am here given for one more clarity. That figure shows the trends in domestic production, import and export of diesel from 16 to 17 to 23rd to 24. I already explained in the previous slide itself. This is once again for here also. That is means we are that is for domestic production is started. So India's demand for diesel is predominantly met through domestic production, indicating that increase the capacity of oil refineries and self sufficiency in refined fuel. So that is indicates for here the green color, and the blue is for that is import. Another one color for that is brown. It's look like brown. It's that is for export. So we are exporting for the year 23rd and 24 also for 0.04. So from 19 to 20 onwards, diesel imports have experienced a sharp decline by 65% annually, signing reduced reliance on imported diesel. So when you are looking for 19 and 20, I think it's we have declining for that is what is that? We are importing for this one, and that is declining for 65% annually, signing reduced reliance on imported diesel. Right. Then for finally that renewable energy sources of electricity. So it's playing an increasingly significant role in India's energy supply, reflecting shift towards cleaner energy sources. So we know that already when you are using for renewable energy means we don't have any other effects, climate change, or other gases cannot be released. So it may be useful for we are thinking earth also to be protected. So the sector shows substantial potential, rapid growth, and is poised to meet India's rising energy demand. The share of renewables, particularly solar, wind, has been steadily increasing from 13 to 14, year 13 to 14, again from 23rd to 24. The primary energy supply from renewable energy sources increased from 17.4 MTOE to 31.1 MTOE, raising its share in overall primary energy supply mix 3.4%. What is the energy mix? So the energy supply is 3.4%. That is a combination of energy sources used to meet the energy needs of a particular region. That is called the energy mix. So 3.4% we are meet out for because of this renewable energy. So renewable energy sources electricity. So once again it's for supply, that is for million tons of oil equivalent it's showing. So we are keep on going on for 23rd and 24th, for gradually it's increased one. And resource potential, I think for the renewable energy resource potentials are that is for estimated by National Institute of Solar Energy, NISA has estimated the country's solar, means India, for potential to be around 748 gigawatt, assuming that 3% of the wasteland area is covered by solar PV modules. So wastelands are covered by solar PV modules. For the so by way of they are estimating that 748 gigawatt is around to be the potential is available in our country. So that is identified by that is National Institute of Solar Energy. They have estimated that for 748 gigawatt of that is a resources potential by way of covering that wasteland area by solar PV modules. So the recent study by National Institute of Wind Energy (NIWE) indicates that India's wind potential at 150 meters above ground level is approximately 1164 gigawatt. That one also identified the solar and wind. So beyond solar and wind, additional renewable resources include 133 gigawatt from large hydro, again that 42 gigawatt from biomass and 21 gigawatt from small hydro. To support the effective integration of these renewable sources, the government has emphasized the development of energy storage systems, particularly through pumped storage projects. India has estimated potential of 176 gigawatt for pumped storage, which can economically convert non-dispatchable renewable energy like wind, solar, and a run of the river hydro into reliable base peak load power. So these are the things identified by that NISC and NIWE for solar as well as for that is wind. Then resource potentials in terms of that is for that is showing in a image. That is for first one is solar, another one for wind at 150 meter it's 1163.9, then for large hydro 133.4, then pumped storage. These are the things are for estimated one by the above two institute, that is for 176.3 pumped storage, then biomass 42.3, then small hydro 21.1. What is the renewable energy installed capacity? I think so far solar rooftop installation in 2017 to 18 with merely 1 gigawatt. So the year 2017, that is 1 gigawatt only they have installed in for solar rooftop installation, and by 24 and 25 as of October 2024 for the last year, this capacity is increased to 14.45 gigawatt, reflecting a yearly growth rate of 46%. So it's an improvement for our country for installing for solar rooftop installation for solar. And another one, the government launched PM Surya, the Prime Minister Surya Ghar Muft Bijli Yojana in February 2024 to accelerate RTS, means rooftop solar installation in the residential category. This scheme aims to install RTS capacity for 1 crore household with the total financial outlay of 75,021 crores. That is for MNRE 2024. They have published that one. So here the right hand side is showing for that solar rooftop image as well as for that the PM schemes also. Then renewable energy installed capacity. I think when you are looking in this image, for the top one is for solar, wind, small hydro, biopower, and the total dot and the bar that for The every year having the bar at the top, one small dot is for the total renewable energy capacity it's showing. That is for announcement to achieve for 175 gigawatt of renewable energy by 2022. They started with the 90. Then from the year 15 to 16, again it started. It's keep on growing for that entire renewable energy capacity. And solar is the top. I think another one for wind, then hydro and bio, everything is there, but solar is always at the top for gradually increasing from the year 15, started from 15, slowly increasing from 7, then 13, 22, 29, 36, 41, and 54, and 67, and 82 for a year 23rd to 24. Then Government of India declares the plan to add 50 gigawatt of renewable energy capacity annually for the next 5 years. So they are also preparing that one for installed capacity for that is making into a country green. Then electricity demand. So the total electricity consumption reached 1,543 ton watt hours during the year 23rd and 24, with a 7% increase from the last year. Further, India's per capita electricity consumption also risen to 1 lakh means 1,395 kilowatt hour. That's one third of the global average as of 23 to 24, nearly doubled over the past decade. That is for Central Electricity Authority. They have identified for this one. From that only I took that one for this data. So 2024 from Central Electric Authority. The next one for industrial sector, which accounts for 42% of the total electricity consumption, plays a vital role in the powering nation's manufacturing and production activities. So this is for that for industrial sector. Then for when you're coming down to that agricultural sector, holds for 17%. So by seeing this word, I think 42% is occupied for industrial sectors. Then only 17% for the total electricity consumed by the agricultural sector. The sector becomes the third largest consumer of electricity with the consistent rise in its consumption. So this keep on growing. So this growth propelled by improved access to electricity, leading to an increased reliance on electric pumps and groundwater irrigation. So so what it indicates means we are slowly I think what is that, we are declining for the oil consumption. So that is the indication for this one for consumption of energy in terms of electricity. And electricity is demand sector-wise electricity consumption. So from railway, the public sector, others, commercial and agriculture, then domestic and industrial, then for total at the top. So every year I think they have started like that only. Electricity consumption for ton watt hour, that is for not ton watt hour, terawatt hours. That is for not ton. Sorry for the one for terawatt hours. So here it's showing for 16 to 17. That is for top one for 1061. When you are coming to that the 23rd and 24, the year 23rd to 24, 1543. Then when you are looking into the right hand side for the color agriculture, so it's keep on increased from that 16 to 17. It's reached for 255 from 191 from 191 terawatt hours to we reached for 255. So it's sector wise electricity consumption. So it's showing the agriculture really depend on for electricity. Then I am taking into consideration for dairy process because it's more consuming one for that that is for an agricultural sector. So India's dairy industry is a major contributor to the country economy, as well as producing large variety of dairy products also. So India is the world largest producer of milk, and dairy products are a significant part of Indian cuisine. Then dairy industry in India is regulated by government agencies, including the Ministry of Animal Husbandry and Dairying and Fisheries, and the Food Safety and Standards Authority of India, that is called FSSAI, that Food Safety and Standards Authority of India. We can see in all the food products they have labeled their that is logo. Another one for these two things are governed for the dairy process, that is dairy industries. Then for considering for milk dairy plant, so these are the process are followed. So that is called for value chain. So it started from that farm, animal produces the milk, then it comes to the farmers, transport milk to milk collection center, then they are coming to that milk collection center from the farmers. That is cool milk for collection and processing. They are doing for that one. The milk collection center, they are doing for cool milk for collection and processing. Then it's going to be transported. That is for milk transport. Raw milk collected and transported to the dairy processing unit. The dairy unit, they are doing all those things for processing of milk for consumer use and other value added products, means allied products of the milk. The downstream transport of transport, that is downstream transport milk and milk products to the consumers. Then consumers at the end utilization of milk and milk products. So this is the processing. This is the processing. This is the original processing happened at everywhere of the dairy industries. They call it as value chain. Then process of milk production. So here it's showing for the cows are there. That is for cows grazing. Then it's for refrigeration storage. Then milking machine twice a day. That is for preparing that one for collecting. Then milk tanker daily to delivery to dairy. Again they are processing for cheese, cream and butter, and milk pasteurized and packaged. Then supermarkets are available. We are also consuming that one. So the process of milk production in a one small image, it's showing for that one from raw to the final product. Okay, then energy consumption in dairy plant. So in I think we have seen for the so many that is value chain for how they are preparing for this one. Now I have given for one image what are the things, what are the energies are needed for the particular process. I have shown in that image, that is heat and electricity for milking, then for electricity for cooling, then for process and packaging, heat and electricity, then transport fuel is needed for cleaning as well as for cleaning. Then for cleaning and water recycling, everything is for process and packaging needed for heat and electricity. So the dairy industry uses energy in the form of steam, hot water, and electricity for processing milk and milk products. So the cost of the energy sources used in the industry increasing continuously because it depends on that we are that is dairy industry depends for the electricity, which in turn increases the processing expenses and therefore the product cost also. So energy cost typically that is constitute 10 to 20% of the overall manufacturing cost. We already discussed in the previous slide. So whenever that production costing, that means harvesting more, whatever it may be for the production cost increases, means the product value also to be increased simultaneously for the profit purpose. Then another one overview for a dairy plant for energy consumption overview. We already have seen in that previous one for that energy consumptions. What are the energies used? Here also once again I listed out the pre-chiller. Its process requirement is cooling. The primary energy is electricity. So secondary energy is chilling media. Then pasteurization, heating, cooling. So natural gas, electricity, steam, chilling media. Then for cold room, cooling. The process requirement is cooling. Again electricity. Then for CIP, cleaning in place. That is called cleaning in place. That is for heating. That is also needed for steam. Then milk powder for making of milk powder. That is needed for heating. For that we are using for steam. Then value added products in allied with for milk. That is value added products. Heating and cooling is needed for that electricity required, and that is for secondary energies for steam and chilling media. So these are the things for equipment is worked for preparing that milk and milk value added products. And for energy balance of your dairy plant. Okay, when you are looking for that right hand side, it's showing for 20%, 20%, and 15%, on 35%. So when you are looking for that green color on the right hand side, it indicates for refrigeration and cold storage. That is the main one for their refrigeration and cold storage, and equally for 20% for milk processing, then utilities and lighting, and again CIP for that is for clean in place. That is, they call it as clean in place. For washing and others, they need for again 20%. So this is the one for a dairy plant energy balance sheet. That is for energy balance graph. So major energy consuming equipment includes the refrigeration system and air compressor, lightings, pumps, motor, homogenizer, evaporating plants, separator and clarifiers, effluent treatment plant, CAP and boilers. So these are the energy balance for one dairy plant. So energy efficiency in the dairy. So dairies have been implementing various energy conservation measures across various production processes. Then energy efficiency at a dairy industry can be viewed into two levels equipment, and the two levels equipment and common level and process level. So they are considering for that is the energy efficiency. They have viewed into two levels. One is for equipment and component level, and another one for process level. So by way of they are doing all those things for making into efficiency. So the energy efficiency at equipment or common level can be achieved by adopting various new technologies, preventive maintenance, optimum utilization, replacement of old equipment with the new and energy efficiency equipment. So in addition to that, improving energy efficiency at equivalent equipment or component level through various energy conservation measures. So here they are doing for so many conservation measures for that one dairy plant for and the case study we can able to see they are doing for conservation measures for from small level to high level. That is such as automation, process control, optimization, process integration, and implementation of new and efficient processes. So these are the energy efficiency in a dairy plant. That the energy efficiency approach in dairy industry. To summarize the energy efficiency strategy for a dairy industry can be focused into three levels. One is for capacity utilization, process automation and control, energy efficient technologies they are using. So three things they are considering for energy efficiency approach. So conservation means here for using less energy for making into more profit. So that conservation. Then another one, energy efficient technologies. That is case study. I have taken for some case studies from a website. That is Tamil Nadu. I think they have the Delhi that the unit is prepared for cluster of so many dairy plant. For example, Tamil Nadu cluster, Coimbatore, Tamil Nadu one cluster. Inside that Coimbatore one cluster, Kerala cluster, Gujarat, like that. So many clusters are there. So they have analyzed they have taken into consideration for what is the drawback, but how we can do all those things for conserving the energy, how we can save the energy, how we can make it into profit for that particular dairy plant at a cluster level cluster. So they have analyzed all those things. So I have taken into taken here for understanding purpose for in terms of case study. So first case is for steam generation and distribution. So conversion of furnace oil fired boiler to fully automated biomass fired boiler. So condensate recovery system. These two things are they have taken care for one particular dairy plant, and they have did all those things for analysis, and they finally they come to the conclusion of what they may do, what they may propose for that, what is the finally what they may get it for in terms of achievement for energy savings and cost savings. Everything is they have listed out. So two things they have considered under the category of steam generation and distribution. For the entire India, they have made it a cluster. Okay, so under that one, conversion of furnace oil fired boiler to biomass fired boiler. So the baseline scenario, the unit has installed two number of three fire oiled furnace, that is ton per hour. That is 3 ton per hour furnace oil fired 3 pass boilers for steam generation, which is used in process applications such as pasteurization, curd marking, and CAP. We already know that for clean in place and crate washing, etc. So they have taken into consideration for that is for 3 tons per hour furnace oiled 3 pass boilers for steam generation. That is, the daily furnace oil consumption of one boiler was identified to be 650 liters per day, with 15 hours working, 15 hours, that is means working per day. So 650 liters per day for the 15 hours working per day. So the average steam demand for them for the particular operation, for 450 to 60 and 600 kg per hour at 7.5 to 10 kg per centimeter square. Normally, the temperature levels for process steam of the dairy plant are below 1300 degrees centigrade. Steam requirement is about 18 to 22 kg per kiloliters of dairy products. So this is the scenario. So they have the cluster team. They have formed the cluster teams and they have analyzed all those things. Then identified this is the problem for them, for that's the losing of the energy or loss everything. So they have proposed the system, the conversion of furnace oil fired boiler to fired by biomass fired boiler. The proposed system replacement, they are going for replacement for the current oil fired boiler, will assist in cutting down the increasing production cost. It is thereby highly recommended to install a new boiler in the plant with the alternative sustainable fuel like wood or briquette. So this usually results in saving of more than 60% in operating cost, and will have attractive payback. So here I have given for the right hand side the image for biomass liquid fuel represents an innovative and eco-friendly alternative conventional energy sources. It is produced through the compression and the heat treatment of biomass material like sawdust, crop straws and agricultural wastes. They are preparing by using these things and it may be reducing that energy for that one, for the particular plant. Okay. So for that, what they make it final, that's cost benefit analysis also they have worked out. The expected fuel savings to be achieved by installation of fully automated biomass fired boiler is for 2,18,363 liters of fired oil annually. So it's coming at the bottom, it's showing for liters of fired oil savings. That annual energy savings also written. That another one for annual greenhouse savings also they have given for that one. In terms of the annual monetary savings for this project is the Indian rupees 36.7 lakhs, 36.79 lakhs with an investment of Indian rupee 60 lakhs and payback within 20 months. So this is the first one for the first case study of one of the cluster. By the I think cluster they developed by the Indian government. They did for the cluster team did for all those things for analysis and they have given for the final outcome of the cost benefit analysis. Then for the second one for that our case study, the first one for under the steam generation and distribution condensate recovery system. Condensate recovery system that is for the baseline scenario. One of the major application of steam pasteurization process is pasteurization process where the milk is heated to 720 degrees centigrade for 16 seconds and quickly cooled to 40 degrees centigrade. So this process slows spoilage caused by microbial growth in the food. So hot water at around 700 degrees centigrade to 800 degrees centigrade used for indirect heating in the pasteurization process. So the condensate after the process heating is currently drained or used in cleaning trades. So this is the condensate recovery for scenario. So what they may happen at that particular plant. So for that they have suggested after that analyzing all those things, the proposed system, the condensate recovery is a process to reuse the water and sensible heat contained in the discharged condensate. Then the second suggestion for the system, recovering condensate instead of draining it can lead to significant savings of energy, chemical treatment and makeup water. Install a flash vessel and condensate transfer pumping unit to recover all the condensate from various processes. Condensate pumping transfer system can pump a huge quantity of condensate effectively utilizing steam known as motive steam. Condensate is one of the purest form of water having low electrical conductivity of only 5 5 or TDS value of 3.5 ppm. That is for their proposed system of for cluster unit given for the suggestion for base after finding that drawback of condensate recovery in the particular plant under the steam generation and distribution. So what is the final one for that cost benefit analysis? Again, energy saving 1.112, that is briquette. I think they may savings when you are using this one. Then another one for ton of briquette is used savings. That one another one annual energy savings also is there. Then no greenhouse gas savings for this case. The expected fuel savings to be achieved by installation of condensate recovery system is 1.1 tons of liquid annually. So the annual monetary saving for this project is for Indian rupee 7.41 lakhs with an investment of 6.4 lakh and payback period of 10 months. Within 10 months, they may take over for that whatever they invested for that one. Right. Then one for another one cluster, they have identified for under the category of refrigeration system. Again, one more dairy plant installation of screw refrigeration compressor. So they have already having for reciprocating compressor. That reciprocating compressor consumes more power. For that, they identified that it's consuming more power. Instead of that, they are going for screw refrigeration compressor. Right. So that is installation of a screw refrigeration compressor proposed system. It's recommended to replace the existing reciprocating compressor with the 155 TR. That is for ton of refrigeration screw compressor is equipped with VFD. So what is VFD? That is variable frequency drive. VFD means variable frequency drive. That is compressor is equipped with variable frequency drive. That is cost benefit analysis. That's the expected savings by installation of screw compressor with the VFD. So variable frequency drive is that is around for 2,79,690 units of electricity annually is savings. That is for expected savings. The annual monetary savings for this project is for 15.38 lakhs with an investment of 52 lakhs and payback period for the project is for 3.44 years. So they have given for kilowatt hour for annual electricity savings and that is for annual energy savings also is given. Then for annual greenhouse savings also is they have given in terms of for the particular installation of that is screw refrigeration compressor for the cluster unit. Another one they have identified for steam generation and distribution and refrigeration system. Then they may come for renewable energy section side, that is for solar rooftop system and a solar wind hybrid system. So they have proposed these two things for the particular cluster. For that, they have achieved for the savings from the cluster units by doing all those things. So first we will look into that for solar rooftop. Already I told you for that is for solar rooftop system is I think implemented everywhere for consuming that one. That is using that one. So the scenario is for the particular plant unit is purchasing electricity from the grid for the power requirement is in its plant. The contracted demand of the plant is 260 kVA. The electricity price that is for 7. That is for that time they have analyzed it with the average load of that is for I think maybe it's old rate. When they have installed for that time they have taken for the kilowatt hour pricing. The average load of 150 kilowatt to 200 kilowatt. The unit has enough rooftop area which can be utilized to install solar PV for self generation of electricity rather than purchasing from the grid. So here they have given for site specification also. So what are all the parameters? So effective rooftop available for 200 square meter true south. So direction also given. The location latitude for 13.05, longitude for 80.25, altitude above sea level for 6.7 meter. The direct normal irradiance 5.08 kilo watt hour per meter square per day. Then wind velocity for 2.8 meter per second. This is the case they have analyzed for the particular dairy plant for installing or proposing for solar rooftop system. After seeing that effective analysis in the site specification for solar PV, they have recommended for proposed system. That is expected savings by installation of 20 kilowatt power for solar rooftop is 40,000 units of electricity annually. So the right hand side showing the images for installation of their solar panel and metering also. So the annual monetary saving for this project is for 2.60 lakh with an investment of 19 lakh and a payback of 7 years. I think again it's showing at the bottom they have that is achieved for annual electricity savings for 40,000 kilowatt hour and annual energy savings also 3.44 for TOE and annual greenhouse savings for 32.80 T CO2. So it's for analyzing for when you are they have suggested. So earlier the case is totally different. So without solar they have connected to the grid. Now they have suggested to the grid. They have reached for the savings. This for solar rooftop. Another one case study is for wind hybrid system. So the wind hybrid system that is solar wind hybrid system. I think it's showing that the images on the right hand side. That is the unit purchasing electricity from the grid for the electrical energy requirement. The contract demand of the plant is 450 kVA and average operating load. The average operating load is for 260 kilowatt to 300 kilowatt. So they proposed so cost benefits for this solar wind hybrid system. The expected savings in electrical energy to be achieved by installation of 50 kilowatt power solar wind hybrid system is for 1,32,000 units annually. So with that the cost of savings for 8.60 lakh with an investment of 45 lakhs and a payback period of 63 months. So again, it's showing for annual electricity savings, annual energy savings, and for greenhouse savings. So I have taken for one small example for understanding purpose of case study in that following processing areas for one dairy plant for comes under the dairy plant comes under for one agricultural sector. So I am going to conclude with this. Thank you, one and all.
Thank you, sir. Thank you, sir.
Can I stop sharing, sir? This one.
Yeah, okay, sir.
Sir, I need sir for this one for taking a photograph or?
Yeah, definitely.
Need,
Murugan,
sir.
sir?
Need, sir. Yes, sir. Yes, sir.
I will keep
Murugan,
the
sir?
first plate.
Yes, sir. Dear participants, please unmute your videos.
Any questions?
Yeah. Questions will be asked later on, sir. After a photo
Yes, sir.
photo
Just a minute.
after
Sir.
photo session.
Yes.
It's come. It's okay?
Yes, sir. Now it's okay. Yes, sir. Dear participants, if you have any questions and queries, now you can ask the speaker, or you can post your questions in the chat box.
A chiన్న suggestion. I think your temperature is showing in a degree Celsius or somewhere you can show 1300 degree or 700, 800. Wherever the temperature showing, in terms of one place is 1300 C. Is it 130?
Just a minute, just a minute, sir. I will look into that.
Similarly, 700, 800 like that.
Okay, just a minute.
But in the milk industries or in the food industries, not.
In the dairy plant,
Yeah.
Okay.
Somewhere.
Okay, sir. Just a minute.
Yeah. If it is 1300, not possible. It be
Okay,
not possible. Okay.
Okay, I will check.
In agriculture sector, a lot of energy saving potentials are available, sir.
Yes, sir.
Lots of energy saving potentials are available.
Energy, sir.
Yeah,
Job
lot of things,
opportunity is there, sir.
Yeah.
Research also is there.
So really, you took very nice presentation, even though you are mechanical engineer.
If you are suggesting our Gurunadhar means sir will definitely involve.
Yeah. Really, yeah, insightful.
I think very much interesting, sir. Very much interesting. But I think they are nowadays not allowing to see that inside. That very difficult to get that even IV also. For Avi,
That's
we
what-
visited Ellur, and Goratur also we visited, but they are restricting for something. Even for they are charging for visit of the students also. Okay, but we can approach, sir. We can approach for consultancy and something.
Yeah, I
How many
visited,
areas?
sir. I visited the Madhavaram. There is a dairy farm is there now
Dairy farm,
available in the
okay.
Red Hills area, that area.
Oh, okay, correct.
I used to go for external examiners, sir. They have
Okay.
dairy plant, college, they are running a separate college, like BE, BTech program, for dairy, food
Correct.
product.
Yeah, correct. But lot of opportunities are there, sir. I think research is good, but available of analyzing all those things is not in our hand. I think very limited colleges having for agricultural program. They are also not meet the requirement of that TNAU, Tamil Nadu Agriculture University, Coimbatore.
Yeah. And Madurai Agriculture University, Coimbatore University, they are leading, I think.
Coimbatore is the main one, sir.
Yeah.
Coimbatore is the main one. They are having for looking all those things, sir.
That's
Like
what
that
I
for AICT, they have for another one body for Indian Council of Agriculture Research. They are coming for that body for conducting all those things. Like that for us AICT, na, for them separate body.
Okay. That's why while fixing this title now, I want to put on a topic in the agriculture sector. That is what
Okay.
I put this topic in FDP program. I thought
sir,
over
yes,
that.
Yes, sir.
And then I find you are the correct persons because you are in the agriculture college now. That is what.
I was in that 8 years. I was in that field, sir.
Yes,
I think for that Savita, I think 5 years. I think 6 years. Students are 3 batches went on.
Okay, good, sir, good.
I have taken. I think subjects also for thermodynamics, for heat and mass transfer.
For them also. Yeah. So,
Yes,
Workshop.
for them also. Same. For variation only for their crop production, dairy, food processing, like that only they are deviation.
Yeah, that's what.
But they have touched all those things. Even surveying also they are studying.
Okay, sir. This nowadays it will be combined ones, hybrid ones, sir. Then only the research will go out.
Interdisciplinary.
Separate means it will not work out. Mechanical means no. Civil, mechanical, agriculture combined together.
IoT, Python.
In future will be like that only, sir. There is no other way.
Correct, sir. Correct. Sir asked one doubt. I think where I think.
Not doubt, it's a suggestion.
For correction.
Unit, yeah.
Unit.
1300 is not possible in put in this.
Okay.
You can put,
Maybe error.
degree Celsius you can put like as
Okay.
Typical error.
Okay.
I will correct it.
Right now, which college you are working, sir, Safi sir?
I am working Savita University.
Oh, inge dana. Okay, right.
Kandalam.
Agriculture, sir. Agriculture department, HOD. Head of the department.
No.
Very good,
I am
very
an HOD. Now totally the HOD is abolished. They are earlier I was a program director for that institute. Now they abolished for that HOD in terms of they are calling for micro HOD.
Okay, sir.
Micro. So for that micro also I am not HOD. Someone is there is for HOD available. I am professor for that particular.
Okay, sir. Any other questions from participants? Same, sir. Yeah, Sadra, sir.
Yeah, sir. So if no other questions, so finally, so let us conclude this highly informative session on agricultural energy storage and conservation, solutions for farmers and ranchers. It is my privilege to extend a heartfelt thanks to our esteemed speaker, Dr. Safi. We are especially grateful for the time and effort you have taken to share your knowledge with us. Your illustrious academic journey, leadership roles, mentorship in research, and commitment to quality education are truly inspiring. Thank you, sir. And a special vote of thanks will be now ordered by Professor Abhilash from Department of Mechanical Engineering, SPCP. Abhilash, sir, please.
Sir, thank you, sir. On behalf of St. Peter's Management, I like to thank Dr. Shafi for accepting our. Hello, sir. Is it audible?
Audible.
Continue.
Special thanks to Dr. Shafi for accepting and is sharing his time to sharing his knowledge. Thank you, sir, once again. And I also thank the management, coordinator, co-coordinator, HOD for giving me the opportunity. Sir, thank you, sir. He enlightening the wonderful energy storage techniques in agriculture, farming, and innovative methods to adapt storage devices. Thank you, sir.
Thank you.
Thank you, sir. Sir, yes. Thank you,
Thank you,
Safi, sir.
Abhilash,
Thank you,
for
Safi,
your,
sir. Thank you, sir.
Yeah. And right now, dear participants, so for all the sections, feedback link has been put in the chat box. For this section also, it has been already shared. So kindly fill up immediately. After filling the feedback form, once again, a Google form will be shared. Right? In that, we are going to write a test. Half an hour time will be given.
சார் இப்பயே ஷேர் பண்ணுமா சார் டெஸ்ட் லிங்க்?
இல்ல கொஞ்சம் ஒரு 10 மினிட்ஸ் இது விட்டுருமா?
10 minutes
ஃப்ரீ.
we can give a break.
பிரேக் விட்டலாம் சார்.
So,
கண்டினியூஸா போயிட்டு இருக்கு.
Yeah.
After
Okay,
feedback,
sir.
Sir, good evening,
After
sir.
filling,
Yes, sir.
Sir, very good evening.
இல்ல
I
6:45
will
க்கு ஆரம்பிச்சு
thank you
திருப்பி
the
பண்ணலாமா சார்?
organizers
பிரேக்
and
போயிட்டு
People's
வரட்டும்.
College,
Wait.
Dr. Chinnapandyan sir.
yes, sir.
Sir, I will thank you all the organizers, including you also.
Yes,
You
sir.
have been completed the definitely a great success. 7 days successfully completed.
Yes, sir. Thank you, sir.
7 days energy gained.
6 days.
Yeah, because the story.
Yes, the entire conversation was based on the energy, and the energy was boosted like anything. So definitely we have been gather a huge amount of the informations regarding the energy conservation, storing, transporting,
Yeah.
how to do this green energy conversion, hydrogen, many things I have been learned in this way. And your team, excellent team.
Yes, sir. Yes,
They
sir.
have did all the problems they rectified within a short span. So it is really a big task you people have did. Really a great advantage, sir. I will congratulate your team, you to complete this successfully.
Thank you, sir. Thank you, Viswa. Deepak, sir.
Welcome, sir. You are always welcome.
Yes, sir. Thank you, sir.
And your team also welcome.
Okay. Okay, sir.
Such a good
Good,
team.
good evening, Professor.
Thank you, sir. Good evening. Good evening.
Thank you. Thank you.
Good evening, Chinnapandyan, sir.
Hey, good evening, sir.
Sir, congratulations, sir. As a
Thank you,
coordinator,
sir.
you have done a fantastic job.
Your support and our real support is only, sir, because of two.
Yes, sir. Yes, sir.
Yeah.
Here,
Thank you,
our
sir.
team, like that, your team, were co-coordinator, Dr. Purushothaman, sir. Sir,
Yes,
congratulations, sir.
Thank
And
you very
much, sir. Thank you.
head of the department, mechanical, St. Peter's College of Engineering, and principal, St. Peter's College of Engineering, and entire team. You had one wonderful team. So they have nicely organized all the events, sir. Congratulations, sir.
Thank you, sir. Thank you, sir. Sir,
Sir, if you
after
could submit, give the online test format, we will complete, and then I have to go to one
Sir.
reception.
yes, sir. Yes, sir.
Now itself, we will complete the test, and then we will move, sir.
So need not give any breaks, sir. Continuously we'll go further.
Then
sir.
continuously, half an hour test only, sir. We
Yes,
will
after
complete,
only.
and then
Sir,
we'll-
for regarding test, I would like to give some instruction. So
Yes, sir.
it will be conducted through Google Form, sir. Google Form only.
Google Form. Okay.
Time is given only 30 minutes. So after
Okay,
that,
sir.
we'll enter the marks into that website portal entry at the ACV portal, and simultaneously give your feedback in the as a participant in the portal. Then attendance
Okay, sir.
already given. Today attendance also updated. So
Okay,
can
sir.
download your certificate, sir. Before 9 or 10 p.m. today.
Yes, sir. Yes, sir. Yes, sir.
Yes, sir. Yes, sir. If there is
now-
any problem, is you can continue for tomorrow and the day after tomorrow. So no problem, sir. We'll help you.
Oh, okay,
Help
sir.
you in all
Sir,
aspects.
test link is shared in chat box, sir.
Huh?
Test link is shared in chat box, sir.
How?
Yes, sir.
Yeah, please
Okay.
give some instruction. Otherwise, straight knots now. 30 minutes only, sir. Beyond that, it will automatically close. Please.
Okay,
Please
sir.
carefully
Okay. Thank
do
you,
it, sir. Carefully do it. So, for all
Okay, sir.
participants, please follow the instruction for 30 minutes only. After that, it will automatically close. Okay, now it starts time. Yeah, but Satrak, sir, this all.
Yes, sir. Thank you, sir. Thank you, sir. Congratulations
sir.
to the entire team, sir.
Yes, sir. Thank you, sir. Thank you, sir.
From my side also, congratulations to entire team, sir.
Thank you, sir. Thank you, Safi, sir.
Sir,
Thank you, Dr.
really,
Sir.
I think when I am looking at brochure, it's wonderful for you are touching all the areas, sir.
That is what. Yes, thank you, sir. Thank you.
Everything you covered a lot within 6
I
days, sir.
took nearly 2 weeks, sir, for fixing title and
hectic work for entire
resource
team.
persons. Yeah.
After submission only, they may be released from that.
Yeah. Thank you, sir. Thank you, sir.
Correct, sir.
Yes.
But
Yes,
anyway,
sir.
I think a lot of energy gained. through this.
Because of our team members, sir. Because of our team members on support,
Yes, yes.
Dr.
Definitely,
Satraj sir, Dr. Purushothaman sir, and
Your teams are very good,
Yeah.
sir. Very coordinative. Coordinative.
yes, sir. Yeah.
Very
Thank
good,
you.
very
Thank you.
Thanks.
Yeah, Abhilash, you can
Leave or head stay, sir.
Yes, sir. Thank you.
ஓபன் ஆயிடுச்சு ஓபன் ஆயிடுச்சு
ஓபன் ஆயிடுச்சா? எத்தனை கப்பு போடணும்?
பார்த்து ஏதோ ஒண்ணு போடுங்க.
1 2 போட்டா போதுமா?
பார்த்து போடுங்க. அரை மணி நேரத்துல க்ளோஸ் பண்ணிடுவாங்க. பார்த்து ஏதாவது போடுங்க மேம்.
சரி சரி. அரபிக்கத்துல 7 தானே ஓபன் பண்றேன்.
Illa sir, people have asked, we can finish it earlier, sir. You want to continue up to 9 o'clock?
இல்ல மீட் பட் சார்.
We'll finish off earlier, sir. Who is speaking now? We'll finish off earlier and then go. No problem, sir. After that, we'll have a validity function, sir. Please attend. After test over, we'll have a validity function with our principal, sir. Please. After half an hour, we'll have a validity function.
Sir, good evening, sir.
Good evening, sir.
The test will be conducted through Atal login or
Yes, sir.
separately
Yes, sir. In other mode also we can conduct, sir. Separately we can have a Google form. Through that we can conduct test, and then test alone mark will be entered separately in the web portal, sir.
Okay.
Both
So now
can we do it, sir?
we have to attempt the Google form which is being circulated by you in the chat box or
Yeah,
we have to go to the
chat box.
Okay, sir.
Only
Fine,
thing
sir.
is, as a participants, you go into that web portal and then feedback give. Already attendance already updated. Mark will be entered. After that, you can automatically your certificates will be downloaded, sir.
Okay.
Before 9 o'clock or 10 o'clock. 9 to 9.
The link will be open. The link will
Open
be
it,
open
sir.
for
Abhilash, sir, please
இல்ல சார் ஓபன் சார்.
open it. Arugan sir, open it.
ஓபன்ல தான் சார் இருக்கு.
Please guide them. Please guide them.
So how much time it will be open for half an hour or 45 minutes?
Yes, half an hour, sir. Only half an hour. As per ACT norms, we are doing, sir. As per
Okay, sir.
ACT
Fine,
norms
sir.
only. As per ACT norms only.
Okay, sir. Thank you, sir. Thank you.
Yes, sir. Yes. Hello?
It's sir.
Yes, sir. Sir, who is speaking?
The link is not there, sir. Devraj, Dr. Devraj.
Yeah, Dr. Devraj, yeah, link is opened for other people. Just now they told that link is opening.
Chinnapandian sir.
சொல்லுங்க சார்.
சார் சொன்ன டிகிரி சென்டிகிரேட் சொன்னாங்க இல்லையா? லோயர் டெம்பரேச்சரா இருக்கும் சார் சொன்னாங்க இல்லையா?
ஆமா.
அது வந்து இது கண்டென்சேட் ரெக்கவரியில வந்து மைக்ரோபியல் ஆக்டிவிட்டியை குறைக்கிறதுக்காக.
அது என்ன இல்ல எவ்வளவு வேல்யூ அது?
720 டிகிரி சென்டிகிரேட் ஃபார் 16 செகண்ட்ஸ்.
ஓகே ஓகே. அது வெறும்
720 டிகிரி சென்டிகிரேட்.
ஓகே. இல்ல 700 அது மாதிரி இருந்தது. இன்னொரு இடத்துல 1300, ஒரு இடத்துல 1300 இருந்தது.
சரி நான் பாக்குறேன். இது வந்து நீங்க சொன்ன லோ டெம்பரேச்சர் ஃபார் வந்து ஃபார் 16 செகண்ட்ஸ் ஃபார் கூல்ட் டு 40 டிகிரி சென்டிகிரேட் bring down to cooled 720 to 40.
அதுதான் 40 C இருந்தது. அது டிகிரி நார்மலா அது 4 C 4 டிகிரி செல்சியஸ்ல கூலிங் இருக்கலாம். 40ல எப்படி கூலிங் இருக்குன்னு தெரியல. அது
40 டிகிரி சென்டிகிரேட்
ஓகே ஓகே ரைட்.
quickly 720 to 40 for microbial death and growth குறைக்கிறதுக்கு.
ஓகே ஓகே ரைட். Thank you, sir.
After test, we will have a validity function with our principal, sir.
Okay, sir.
How many people
Yes,
are rating this test?
Yes, sir.
115, 116?
Yes, sir. Yeah, already, yes, sir. Somebody exit in the team, sir, and doing the test, sir.
Okay. Yeah, sir.
They are taking the link only, then doing the test separately.
Okay, sir.
Sir, good evening. I am Vishwadeepak. Actually, when I am logging to my portal, sir, it is showing me that there are some instructions. You can take a test form onwards. Your response will not be saved until you select your response and click either mark and review. So while there will be a tick mark, once I am clicking the tick mark, it is showing that the question not submitted.
No, sir, you should not go to portal, sir. This is a separate link is there.
Yeah, separate only. Yes, sir.
Need not go to web portal. There you make feedback alone. You fill it, sir. Attendance and mark, everything attendance already updated. Mark will be given another after your test over.
What I am asking, where is the link? Link it is not in chat.
Murugan sir, once again put it in the chat box for test link.
Okay, sir.
So finish one by one, sir. Don't do it parallelly because otherwise time will exceed. For test only 30 minutes.
Whether we need to log into Atal portal and write test again, sir, or only the Google form what you have shared is enough, sir?
Is enough, sir. Google form test is enough, sir. But
Okay, sir.
again, you have to go to as a participant in the web portal. Then you have to give feedback.
Yes, sir. Yes, sir. Okay, sir. Yes, sir. Thank you, sir.
Okay.
Yes.
Dr. Chinnapandian, sir.
Yes, sir.
Sir, I'm
Chandrasekharan, sir.
Chandrasekharan, professor, SRM University.
Welcome, bro, sir. Test mark will be updated
right.
automatically in another 1 hour.
Okay, thank you.
Thank you, sir. Thank you, sir.
சார் சின்னப்பாண்டியன் சார் கஜேந்திரன்
Sir,
கஜேந்திரன் பேசுறேன்.
Gajendran, சொல்லுங்க Gajendran.
கம்ப்ளீட் பண்ணியாச்சு. டெஸ்ட் கம்ப்ளீட் பண்ணியாச்சு. முடிஞ்சது.
Web portal wait as a participant give a feedback.
ஓகே ஓகே.
Stay back, sir. We'll have a valid function.
ஓகே சார் ஓகே.
Okay. Be here. Stay here. Murugan, sir. Murugan Abhilash, somebody asks the send test link, send test line. Okay. Please, once again, again put it.
Okay,
test.
sir. Okay, sir.
Under the name of test.
Okay, again.
Sir, good evening, sir. Chinnapandian, sir.
Who is speaking, sir?
Manivannan, sir.
Yes, sir. Yes, sir.
Sir, I have attended all the sessions, sir. I have submitted all the feedback form for all the 6 days, but my attendance is marked absent in Atal portal, sir.
We'll verify, sir. We'll verify. We'll sort out problem. Don't worry, sir. We'll do it.
Okay, sir. Okay, sir.
Good afternoon, sir. I am Selvasundaram from Tirunelveli, sir.
Yes, sir.
Sir, I will attend all the programs, sir, and submit the attendance and feedback, sir. But Atal website, my attendance will be Monday with absent port, sir.
Your came in other name, sir. I do not know why your people are now. Your came in other number or why it is?
Sir,
he made a separate participant list. He made a separate participant list.
Yes, sir.
And then their name is not. I do not know. I have put separate in the WhatsApp group also. Some nearly 15 people are showing not attendance in
Yes,
our
sir.
registered things WhatsApp group and attendance also. That is what.
Okay.
We identify some nearly 15 people of. We do not know whether you are in came in some other mode or do not know. 1 second, we'll verify, sir.
Okay, sir. Thank you, sir. I submit as a test, sir.
Okay.
Okay.
Once the test over, be here, sir. Stay back for validity function, sir. I request you to stay back once you completed a test.
Sir, can you tell how many times left to complete the exam?
Half an hour, sir. Half an hour only.
Participants, those who have completed the test, kindly log in your Atal portal and submit your feedback form over there. I repeat, participants who have completed the online test by using Google form, so you kindly log in your Atal portal with your ID and
As a
submit
participant.
the feedback
As a participant.
form over there.
As a participant.
So after complete, just you wait. We will start the validity function very soon.
Sir, excuse me. Sir, I am Chandrasekharan, professor mechanical, SRM.
Test mark is enabled, not enabled. Test mark.
Yeah, that we have to upload, sir.
Okay, sir. Okay,
So
fine.
after collecting the Google form, from that we will upload your test marks. So you have to wait.
Okay, sir. Okay, sir. Okay, sir. Sir, only you can download certificate afterwards. Yes, sir.
Yeah. After uploading your marks, only you are eligible to download your certificate. So you have to wait for this process. So after receiving all the Google forms from all the participants, we will make entry the marks.
When will the validity
And
function start,
already
sir?
so many. Pardon, 1 second.
Validity function. My name is Dr. Chandrasekharan, professor mechanical, SRM University.
Welcome, sir. Welcome, sir. Nice to meet you.
Validity function.
Sir, I couldn't. Yeah, within few minutes we will start, sir. Just another 15 minutes.
Thank you. Okay, thank you, sir. Thank you very much.
And if you have any queries related to your attendance, just type your name and the respective dates and place in the Atal WhatsApp group so that we will rectify the problem. Already nearly 4 or 5 participants have already insisted that they have problem in attendance. It has been marked as absent. So those participants, kindly type your login ID, your name and the day of attendance which has been marked as absent, so that we will look it out and sort out the problem.
Sir, exam submitted, then what we have to do further, sir, after submitting the examination?
So you have to log in your AICT portal and complete your feedback form over there.
Okay, now itself or after half an hour also
Now
you can
only.
do? Now itself we have
Now
to do.
just you can complete, sir. Just another 2 minutes it will take hardly.
Okay, sir. Thank you.
Chinnapandi, sir.
Sir? Yes, sir?
This is Karthikeyan from SR Madabani.
Yes, sir.
Sir, one thing what I found as my mistake, in all the Google form what I have submitted, I have used my personal mail ID,
Okay.
whereas my official mail ID was the registered one. But my attendance were uploaded in the Atal website. I could find my attendance there.
Oh, no problem. See, whatever the Google form you fill, the marks will come to ours only.
Okay.
So that mark will automatically upload, update.
You would identify based on the ID and the name given, not with the mail ID. Because I have mentioned my personal mail ID in all the Google forms submitted to you.
Okay.
Which is a mistake. But my attendance were posted there.
Okay,
The
so
website.
update, already attendance is updated, sir.
Yes. Okay.
Okay.
Similarly, you upload the marks also. One thing I want to know from you, the Atal feedback, the order of the marks are given in the reverse. You have given the excellent as the first one in all your feedback. But there, to agree the statement, it says that 5. You clarify with all the participants, because by mistake, if we give the wrong number, that instruction, you please read it once again to all the participants.
Nothing, sir. Could not what follow. What is, sir? What do you want to tell, sir? Please.
You go to the Atal site in the feedback.
Okay, feedback.
For strongly agree, I think we have to give the number 5.
Number 5. Okay.
So that is in the reverse order, because in all your feedback, the excellent was on the top.
Sir,
In all your Google form, the excellent was given as the topmost one.
I see.
Here to give the
சார் பாயிண்ட் வந்து அதே பாயிண்ட் தான் சார். கார்த்திகேயன் சார், அதாவது 5 வந்து மேக்ஸிமம் பாயிண்ட், அதான் கான்செப்ட். ஸோ அவங்க வந்து என்னன்னா 5 வந்து மேக்ஸிமம், 1 வந்து டிசக்ரியில இருந்துச்சு. அதே கான்செப்ட் தான் அவங்க 1 to 5 கொடுத்தாங்க.
Organizer can decide this grade and other things. It is, don't worry about this. Organizer is having the
ரெண்டு இடத்துலயும் ஒரே மாதிரி தான் கொடுத்திருக்கு. They have given it as 5. 5 வந்து agree.
Strongly agree.
இது வந்து disagree. அவ்வளவுதான் சார். இவங்க ஆர்டர் வந்து மாத்திருக்காங்க. 5 4 3 2 1 இருக்கு. இங்க 1 2 3 4 5 இருக்கு.
By mistake, if you
அது ஒண்ணும் பிரச்சனை இல்ல. நாமக்கலஸ் சேஞ்ச் ஆயிருக்குதுங்க.
Yes.
So whatever the Google for that is you are giving, that will accepted, sir. No problem, sir.
சார் இல்ல சின்னப்பண்டி அவர் சொல்றது என்னன்னா, ஆமா நீங்க வந்து ஃபர்ஸ்ட் ஃபீட்பேக் கேட்டது எப்படி கேட்டிருக்கீங்கன்னா 5 4 3 2 1 இருக்கு. அதாவது 5 வந்து ஸ்ட்ராங்லி அக்ரி, 1 வந்து இது. நீங்க வந்து 5 4 கொடுத்துருக்கீங்க. அவங்க வந்து என்ன எப்படி கொடுத்துருக்காங்கன்னா 1 2 3 4 5 கொடுத்துருக்கான். அதாவது இன்க்ரீசிங் ஆர்டர்ல போகுது. அவ்வளவுதான்.
ஒன்னு வந்து
ரெண்டு பேருக்கும் கான்செப்ட் ஒண்ணுதான். பட் நீங்க வந்து ரிவர்ஸ் ஆர்டர்ல கொடுத்துருக்கீங்க, அவங்க இன்க்ரீசிங் ஆர்டர்ல கொடுத்துருக்காங்க. அவ்வளவுதான் வித்தியாசம்.
ஒன்னும் ப்ராப்ளம் இல்ல சார். ப்ராப்ளம்
பாயிண்ட் வந்து அங்கேதான், அதேதான். அது வந்து வேரியேஷன் கிடையாது. 1 வந்து டிசக்ரி, இது வந்து 5 வந்து
ப்ராப்ளம். By mistake, if we press the 1, you will get the wrong feedback.
They have to read out. They have to read out properly there.
That's what, sir. After all your hard work, you may lose the feedback. Yes, I'm giving an alert to you. That's all.
Okay, sir. Okay.
So, what I say is, you generally give an instruction that would be better.
Okay, that is what we will follow it, sir. Now it's we will do it next time, yes, sir.
Sir, good evening.
Good evening, sir.
Sir, what's the minimum mark you have to get?
70 marks, sir.
70, sir. 70.
Above 70,
sir.
ரீடெஸ்ட் கொடுப்பீங்களான்னு கேக்குறாரு.
Let us see, sir. Let us discuss with concerned people, sir. ACD people will ask, sir. Okay, sir.
Certificate will come.
Yeah, we will ask the concerned people to. We'll ask the concerned people, then we'll have a retest, sir.
Okay, sir. Thank you, sir. Thank you.
Thanks.
Sir, I have completed my test, sir. I have to go to portal, and what I have to do, sir? Login and then
go to portal as a participant.
Participant.
As usual.
Okay.
Then go and fill the feedback there. Already attendance is updated. Mark
Okay, sir.
also another half an hour will be updated. Mark your whatever the mark you got, that will be updated another half an hour.
Okay,
Then
sir. I
once
have
you finish everything, you can download your certificates. Okay.
Okay, sir.
Hello, good evening, sir.
Good evening, madam.
Sir, my attendance is not updated, sir, in Atal WebDP portal.
உங்க இது what you telling sir? Your attendance.
4030A404, sir. Benisha.
104.
104.
Benisha, huh?
Yes, sir. Yes, sir.
Not for
But I attend all the sessions, sir.
Yeah, we'll take into account, madam. We'll inform the concerned people.
Okay, sir. Okay.
Okay, ma'am.
Okay, sir.
Sir, good evening, sir.
Good evening, sir.
I am Rajendran VK, AMK Technological Polytechnic College.
Yes, sir.
Okay, I completed question answer also, and I attended all the sessions, sir. I got updated the attendance also.
Okay.
Okay, then how can you download the? Can I get the certificate through email, sir?
Yes, sir. Sir, mark will be updated in another half an hour, sir. Another half an hour, 1 hour. After that,
Okay.
you can download your certificates. Yes, sir.
Through email or
No,
through
from
email
the
or
portal.
I go to
No, from
From the portal only. From the portal only. Your portal as a participant now. From the portal you can download.
Okay, thank you, sir. Thank you very much.
Good evening, Professor Chinnapandian.
Yes, sir. Yes, sir.
This is Kaliraj from Madurai.
Yeah.
Submitted.
Very good. Then you go to AS web portal as a participant. There you finish your feedback. Okay, Kaliraj?
Now, just now I can switch over it, or afterwards, after completion of validatory function, I'll have to go there.
No. You once you go now, you finish your feedback there in the portal. After that, you come again for validatory function.
Okay, thank you. Hello.
Hello, sir.
Sir, good evening, sir.
Good evening, sir.
Sir, this is Vaiti from Perry Institute of Technology.
Okay.
Yes, I attended all sessions. In website, it's also mentioning person. Today I attended. I completed my test also.
Attendance is marked. Attendance is everything. Attendance. What is your problem, sir?
Sir, there is no problem, sir.
Okay,
Sir, I
sir.
want to know at what time mark will be displayed.
That will be updated, sir, very soon. Okay.
Okay, sir. Okay. Thank you very much, sir.
Yes, sir.
Hello, sir.
Hello, sir.
Sir, how to submit the feedback, sir? I'm in Atal web portal.
Sir, separate Google form is provided in the chat box. You fill the Google Forms box and then.
That feedbacks and all I filled, sir. But you are saying that in Atal web portal login, we have to fill one feedback. No, that's what
that feedback. Yeah, you have to fill it on your own. For about the speaker, you have to give feedback about the speakers.
Yes, sir. But in feedback, it's not opening. The status is submitted. No, it's showing. கீழே ஃபீட்பேக்னு ஒன்று இருக்கு சார். அசஸ்மெண்ட்
அதை கிளிக் பண்ணுங்க. அதை ஃபில் பண்ணுங்க முடிஞ்சது.
இல்ல சார், அதை கிளிக் பண்ணாதான் எதுவுமே வர மாட்டேங்குது. அது ஆக்சுவலா ஃபீட்பேக் சப்மிட்டட் நோன் வருது, அவ்வளவுதான்.
அப்போ உங்க டீடைல்ஸ் அட்டெண்டன்ஸ் என்டர் பண்ணிருக்காங்களா, மார்க் என்டர் இருக்கு. அட்டெண்டன்ஸ் என்டர் ஆனா தான் அது வரும், இல்லன்னா வராது.
அட்டெண்டன்ஸும் இல்ல சார் அதுல.
உங்க பேர் சார்?
சக்திவேல் சார்.
சக்திவேல், நீங்க ரிஜிஸ்டர் பண்ணிருக்கீங்களா?
எஸ் சார், ரெஜிஸ்டர் பண்ணியிருக்கேன். நான் எல்லா நாளும் அட்டன் பண்ணியிருக்கேன். ஏற்கனவே ஒருத்தர் ஒரு ப்ராப்ளம் சொன்னார் இல்லைங்களா, நான் பர்சனல் லாகின்ல என்டர் ஆனேன் இதுல. பட் நான் ரெஜிஸ்டர் பண்ணியிருக்கிறது அட்டல்ல வந்து என்னோட அபிஷியல் இதுல ரெஜிஸ்டர் பண்ணியிருக்கேன்.
அப்ப நீங்க அபிஷியல் இமெயில் ஐடியில் தான் போகணும், அப்பதான் வரும்.
அபிஷியல் மெயில் ஐடி உள்ள அட்டல் லாகின் பண்ணிட்டேன் சார். பட் இங்க நான் ஃபீட்பேக் ஃபில் பண்ண எல்லாமே வந்து என்னோட பர்சனல் லாகின்ல ஃபில் பண்ணிட்டேன். நான் எதுல பண்ணேன்னு தெரியல. நான் யூசுவலா அதுல பண்ணிட்டு இருந்தேன்
சார். நீங்க தான் கேர்ஃபுல்லா இருக்கணும் சார். நீங்க அட்டல்ல எந்த போர்ட்டல்ல பார்ட்டிசிபென்ட்ஸோ எந்த ஐடியில பண்ணீங்களோ அதுல ஓபன் பண்ணீங்கன்னா தான் உங்க ரெஜிஸ்ட்ரேஷன் காமிக்க முடியும், இல்லைன்னா வராது.
Chinnapandian sir, shall we start the validatory?
Sir, shall we start? Murugan Purushottam sir.
So good evening everyone. It is very great honor and gratitude that I extend a warm welcome to all of you to the validatory session of the Atal Faculty Development Program on Energy Conservation and Storage Technologies for Global Sustainable Developments. It is my great pleasure to extend a warm and heartfelt welcome to our esteemed Principal Dr. S. Purnachandra, and he is a visionary leader, an accomplished academician, and a dedicated administrator whose guidance and commitment have been instrumental in shaping the academic excellence of our institution. Under his leadership, we have witnessed significant growth in research, innovation, and quality education, fostering a culture of learning and excellence. Sir, it's a great honor for all of us, and we truly appreciate your continuous support, encouragement, and dedication to empowering both faculty and students. Your insights and vision continue to inspire us as we strive for great achievements in our academic and professional journeys. On behalf of everyone present over here, I extend my warmest welcome to Dr. S. Purnachandra and look forward to an engaging and enlightening session. Thank you, sir. Next, it is my pleasure to extend a warm welcome to Dr. M. CHINNAPANDIAN, our esteemed coordinator and professor of this FDP. His dedication and expertise have been invaluable in shaping this faculty development program and ensuring its success. Sir, we truly appreciate your leadership, commitment, and efforts in organizing this initiative, which provides a platform for learning and collaboration among faculty and researchers. On behalf of everyone present, I extend a warm and heartfelt welcome to Dr. M. CHINNAPANDIAN and look forward to an insightful session ahead. Thank you, sir. And I am extending my warm welcome to Dr. K. Purushottaman, our esteemed co-coordinator and professor, Department of Mechanical Engineering at St. Peter's College of Engineering and Technology. His dedication and efforts have played a key role in the success of this FDP, ensuring a valuable learning experience for all. Sir, we sincerely appreciate your efforts and leadership making this program impactful. On behalf of everyone, I extend a warm welcome. And I extend the welcome to all well-distinguished professors from across India as a participant in this Atal FDP platform. It is with great pleasure and appreciation and heartfelt welcome to all the faculty members and professors joining us from institutions across India once again. Your presence here today reflects a third commitment to knowledge, innovation, and academic excellence. This gathering of brilliant minds from diverse backgrounds fosters a collaborative environment where ideas can flourish and meaningful discussions can shape the future of education, research, and technological advancements. You are truly honored to have such a distinguished group of educators participating in this faculty development program. Your dedication to continuous learning and professional growth inspiring, and we look forward to enriching an exchange of ideas throughout this year. Once again, a warm welcome to all the beloved participants. And finally, I welcome all the faculties of our mechanical department who shouldered us throughout all the 6 days of this FDP, and their dedication plays a vital and key role in making the FDP a grand success. As well as I extend my welcome to all other department faculties of SPCT who have joined this FDP and made a great decoration. And over the past few days from February 3rd to March 8th till now, we have embarked on a remarkable learning journey, gaining deep insights into cutting-edge technologies, innovative solutions, and best practices in energy conservation and storage. This FDP has provided a platform for knowledge exchange, meaningful discussions, and collaboration among experts, researchers, and academicians dedicated to advancing sustainable energy solutions. The sessions conducted by our distinguished speakers have enriched our understanding and inspired us to think beyond conventional approaches. On behalf of the organizing team, I express my heartfelt gratitude to all the esteemed speakers, starting from the very first day towards till day, the resource persons from industries, share their invaluable knowledge and experts. And I special thank to AICT Atal Academy, our institution leaders, have made this FDP a success. As we move forward, once again, I warm welcome to all the persons who are in this platform. Now I request Coordinator Dr. M. CHINNAPANDIAN to give an overall glimpse of the FDP so far went on. I welcome you, sir.
Thank you, sir. Thank you, Dr. Shatrani Jaisagaran, HOD Mechanic Department, for welcoming all participants. Thank you once again. I will conclude the remarks. So the program, the FDP program title on energy conservation storage technology for global sustainable development started with our Gurunatha Dr. R. Velraj on 3/2/2025 inaugurated very nicely and given a very informative session. After that, he has handled the first session, the topic thermal energy storage for solar energy utilization. He spoke about various, if we take away key takeaways from his speech, renewable energy integration, the importance of integrating renewable energy sources into the grid to reduce dependence on fossil fuel and mitigate climate change, energy efficiency, energy storage solutions, and then sustainable developments, global cooperation. Like that, he has spoken various aspects, and then actionable recommendation is given from this FDP. So invest in renewable energy. Governments and industries should invest in renewable energy sources such as solar, wind, and hydropower. This is what from FDP we are actionable recommendation giving to the government. To develop energy storage infrastructures, governments and industries should develop energy storage infrastructures, including batteries, hydrogen fuel cells, and then promote energy efficiency, support research and development, foster international collaboration, future directions, and electrification of transportation, smart grids and energy management. So like that, he has focused, and all other speakers also spoke about all the, and the title stick to that. What is that second session handled by, and the same day, Mr. Ashok Sedaraman in the title Industry Energy Efficiency Opportunities and Challenges. And then fourth day, third session started with the international speaker, Dr. Maria Rajesh, Professor Civil Section, and the topic thermal insulation using sustainable material, promoting energy efficient building. And then same day on fourth session, spoke by Mr. B. Rajendran in the title Global Energy Storage and Conservation Trends and Outlook. And third day on 5th to 2020-25, I spoke about carbon capture in CA engine environmental effect by Dr. S. Murugan, Professor Department of Mechanical Engineering in NIT, Rourkela, Odisha. He is focused on carbon captures and then storage, about energy storage technology. So he has given a very insight topic on that same topic, same that. Then the next same day on 5th to 2025, sixth session, Mr. T. Ponnurangam, wind energy storage solutions. He spoke about wind energy solutions on that. What are the assessments to be carried out? How to calculate wind sites and all. He has spoken very nicely. And then 6 to 2025. Ms. Dr. K. Karupasamy, Assistant Professor, Department of Mechanical and University. He spoke on transportation energy storage and sustainable features. So what is transportation, various transportation sectors, starting renewable energy, how the what is conventional fuels, renewable fuels, and then hydrogens. He talked about various and how the pollutions are produced, everything he has taken clearly about in that session. And then same day, 8th session, Mr. Somase Nayak from hydrogen engine and after treatment mobility group New Energy Initiative spoke about hydrogen storage. He has taken insight into the hydrogen storage application and infrastructure developments, because nowadays is a progressive one. The topic is very trendy now, hydrogen storage. He has given very nice presentation overall. Okay, and then next 7th session start with Ilango Ram Suppu. He has spoken about emerging renewable energy technology and storage. He has given again the storage technology, in-depth knowledge in storage technology about methane, and all he has spoken very nicely. And then same day on 7th to 2025, session 10, Dr. D. Ruben Sudhakar, he spoken on topic battery storage system, lithium ion, flow battery and sodium, everything. He has spoken very well on this same topic. Then today, myself spoken on cascade latent storage system and heat recovery. Then after that, Dr. K. Purushottaman, he has spoken well on community bioenergy storage, opportunities and benefits. Okay, how it's available, and he has insightful given knowledge in the community bioenergy storage. Okay, so and then today third session with Dr. Shafi. and that he has spoken on the topic agriculture, energy storage and conservation, solution for farmers and ranchers. So from this, all speakers have spoken very well. Definitely, we appreciate all our speakers. Then the key takeaway from these points. So as we conclude this FDP on energy conservation storage technology for global sustainable developments, we hope that the knowledge, insights, and connections made here will inspire and empower you to contribute to your sustainable energy features. So this is what take away from our FDP program. Okay, this is what I would like to mention for these things. Okay, thank you, Dr. Sairam sir. Concluding remarks. Yeah.
Thank you, sir. Thank you, sir. Thank you for your valuable glimpse that you have come across from February 3rd to till date. Once again, you have made to think all the sessions to our mind. Thank you so much for your overall feedback. Now, I request our honorable and distinguished principal, Dr. Purnachandra, to deliver the valedictory address. Welcome, sir. Okay, sir. So, hence, I think due to some administrative reason, so principal has not joined the address. So anyhow, so the valedictory address will be given by our coordinator, Dr. K. Purushothaman. So I welcome you for the valedictory address, sir. Please, sir.
Yeah. Good afternoon. Good afternoon, one and all present here. Once again, I welcome all the participant and organizer, or principal, for this 6-day Atal FDP program in energy conservations and sustainable technologies. Really is a wonderful session. I think 100% attended this program. Even though we are saying thermal energy people, but in this program we learned lot of technologies in practically latest knowledge. Technology they're using in the practically. So I think I understood also as a participant, as an organizer, and maybe the same thing is useful to other participants also. I request all the participants, those who are currently doing PhD, or you can involve in this energy technologies. The thermal energy technologies. So you can make use this opportunity. If any help, you can contact Dr. Chinnapandian sir or myself. Through him I will guide you to do any research on this particular energy conservation and energy auditing, energy conversion, everything. And this is a time to appreciate our coordinator. So he put me as a co-coordinator. Really, I apologize for all the organizer because I'm busy with some other activities conducting examinations. I think it's 100% credit goes to our Chinnapandi sir only. He only fixed all the speakers and schedules, approaches with help of our department faculty members with Dr. Shatrak, Abhilash, Jabamani sir and Murugan and Vinod. Okay, really appreciate the team is working and completing successfully, and it may be useful all the parties. Useful to the participants. So once again, I congratulate all the organizer and participant and the speakers. Those spend a lot of time to sharing their knowledge. So this is a time to thanks to all the speakers and organizers and participants. So on behalf of co-coordinator, I once again thank you very much for arranging this such a kind of the energy transfer. So far we are talking about the thermal energy, but now we are technology transfer to all the peoples from the industrial people and interconnecting between the industrial people and academicians and professors and researchers. This is a forum for conveying all the take home the energies for last 6 days. Thank you very much for giving me the opportunity, and all the best for all the participants, and congratulations once again the organizer. Thank you very much. Thank you, sir.
Thank you, sir. Thank you, Dr. K. Purushothaman, Professor and COE, of St. Peter's who have given a remarkable valedictory address in spite of our principal absentia. Okay, now this is the time for our beloved participants. So I request any of the participants so that you can unmute your mic and you can share your feedback. So we can give opportunity for any three participants.
Yeah, good evening, the head of the department, the controller of examinations, myself, Ishwaramurthy. I am one of the participants joining from Jammu and Kashmir, where Professor CHINNAPANDIAN sir is organizing this an event on the topic of energy conservation and energy storage. It's a combination of two words, which is attracting the people's almost 140 participants. So the speakers, without participants, with the speakers, nothing is possible. That 140 participants for an online in the evening, 6 to 9, everybody is having the family life, even including our organizers, but they committed for this job and they delivered the lectures, and people are what you call that, and really what you call that, participated in all the sessions, even including Saturday. You might be having a working day, but we are in off. But we attended from the sessions from 2 o'clock, since 2 to 3:30 I was occupied with some other course. Really, it's a wonderful job, sir. But I want to really congratulate Dr. Chinnapandian, sir. He took an interest to submit the proposal. I think it's 3 months back when AICT is called and the online Google form, probably they submitted. From then it is approval is come, then they want to start the process. So really it's wonderful, it's a learning experience, and also networking. It is an outcome, that is a way it is in we can find out. Also, I request, as my institute lives in Jammu and Kashmir, very close to what you call the 80 kilometers international border. If you have an interest, you can visit our university for so any technical point, or if you happen want to visit Mada Vaishno Devi, you can also most welcome, sir. So that's all from my side. I want to congratulate the coordinator Dr. Chinnapandian and his co-coordinator Dr. Purushottaman. Thanks for giving him an opportunity. Thank you.
Thank you, sir. Thank you, sir.
Thank you very much, sir.
Thank you, sir.
Pandian sir,
Yeah.
Dr. Chinnapandian sir,
Yes, sir. Yes, sir.
Purushothaman sir, thanks for the opportunity provided by the organizers for attending the program throughout all the sessions. Very the knowledgeable resource literatures we had heard. The world scientist Professor Dr. R. Velrajar, our guru, the first session and the session chaired by Professor Chinnapandian, Purushottaman, all the sessions starting from the Sultanate of Oman Professor and all other professors, our Professor Shafi, all our professors Punnurangam, and the ever new technologies, that persons, the first day auditor, energy auditor, Professor Seduraman, all the lectures are very nice, sir. Thanks for the opportunity provided for me for attending the program. Myself, I am attending in Chidambaram LA at Microsoft.com, but I had provided the feedback at Professor Dr. Elia Chidambaram at gmail.com. Kindly see that thing also, sir. Thanks for the opportunity for providing me. Thank you, sir. Thank you.
Thank you, sir. Thank you, Dr. Chidambaram, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Dear
Any other participant?
dear organizers, this is Karthikeyan from SRM Madapani. See, we usually say a good start is of the success. So that is the way this program has been well defined. You had a very good, the topics selected and all the resource persons you have selected are very good in their respective areas. So the inauguration session was done by Dr. Velraj, Vice Chancellor of Anna University. So that itself has given a very good impact. So a very good start usually we say it's half the success. So that way the program has went well. So we enjoyed all the sessions, useful and very informative. Though we are all professors, there were a lot of takeaways we could get from all the sessions of these 6 days FDP. I once again congratulate and thank the coordinator and all the co-organizers for this wonderful event. Thank you all.
Thank you, sir. Thank you, Dr. Karthikeyan, sir. Thank you.
Thank you, sir. Thank you, Karthikeyan.
Thank you, sir.
Hello, everyone.
Okay.
Am I allowed?
So with this, yes.
Just
Are we
introduce
still
your name,
getting the
madam.
feedback from the participants?
Yeah. Continue, madam.
Yes, Namaskar. I am Manashita Bora from Tezpur University, Assam, the northeastern part of India. And I thank Professor CHINNAPANDIAN, if I'm not mistaken in pronouncing your name. I had called you, I think, a couple of times, and you were very prompt in replying and very active in responding to all my queries. Thank you for being so active and organizing this wonderful FTP. My only concern is, it's not a concern, maybe a future suggestion which we might think is useful. I have attended a couple of more FTPs, which I often attend on and off in my free time, especially related to this topic because I personally work and do research in energy storage technologies. That is also where my PhD scholars and my team works here. It would be great if the information regarding the sessions of the FDP are also circulated in the official or the registered email IDs along with the social media platform like WhatsApp. It would be convenient for us because some of us are not really that active in social media like WhatsApp. And everything was wonderful, and I loved all the topics, and we had wonderful speakers. Thank you for sharing the knowledge.
Thank you, ma'am. Thank you, madam. Thank you.
Thank you, ma'am. Definitely, we'll consider your request. We'll continue in the futures.
Thank you, Dr. Bora. So very nice comment, nice compliment to CHINNAPANDIAN, sir. You covered that northeastern to north and south. Very great.
Yeah. Yes, sir. Any more from any more participants would like to give?
Sir.
Yes.
Okay. So let us conclude our FDP. So now I invite Dr. M. CHINNAPANDIAN to deliver the vote of thanks.
Yeah. Good evening to all esteemed participants and organizers. As we came to the end of this enriching faculty development program, I would like to take a moment to express our heartfelt gratitude to everyone involved in this FDP. First and foremost, we would like to thank our esteemed speakers who have shared their valuable expertise and insight with us over the past 6 days. Your presentation have been informative, engaging, and thought-provoking, and we are grateful for the time and effort you have taken to prepare and deliver them. We would also like to thank our participants. Your active participant questions and discussion have enriched our learning experience, and we are grateful for your enthusiasm and commitment to the field of energy conservation and storage technology. As we conclude this program, we hope that the knowledge, insights, and connections made here will inspire and empower us to contribute to a sustainable energy future. Once again, thank you all for your contribution to this program. We look forward to staying connected and continuing the conversation on energy conservation and storage technology. Please join me in thanking our speakers, participants, ACT people who have sanctioned this FDP to conduct through online management of St. Peter's College of Engineering Technology, who have supported and provided advance amount rupees 75,000 towards expense of honorarium to our speakers. Honorable beloved Principal Sir, for constant support. And co-coordinator is Dr. K. Purushothaman sir, constant support, and HOD mechanic Dr. Sautrak Jaisagaran, faculty members who have involved, dedicated. Really, I appreciate all our faculty members and thankful. Start from Abhilash and Satyamurthy and Jabamani and Vinod and all other faculty members who have given nice support to conduct this program in a nice manner.
Murugan.
Murugan, I spell Murugan. Yes, throughout the day, we started in any time. He has helped a lot for making this program in a very successful manner. For making this faculty development program a resounding success. So thank you once again for all people who involved in this. Thank you once again, all participants. Thank you for all. Good evening to all. Thank you.
Thank you, sir. Dr. CHINNAPANDIAN, sir.
Yes.
Thank you. Last but not least, my gratitude to the technical and administrative teams who work behind the scenes to ensure seamless coordination, making this event a great success. As we conclude this program, let us take forward the knowledge gained and apply it to create a more sustainable, energy efficient future. Once again, thank you all for the participants, making this FDP a meaningful and memorable experience. Wishing you all the best in your future endeavors. Thank you all.
Thank you, sir.
Thank you very much.